Okay, today we're covering 2.4, families of polynomial functions. So by the end of today, you should be able to determine the equation of the family of polynomial functions with a given set of zeros. You should also be able to determine a specific equation for a polynomial function if you're given a set of zeros and a point. All right, so we discussed this in grade 11. So a family of functions is a set of functions with the sum of the same characteristics. And the big characteristic that is the same is that they have the same x-intercepts. So as long as two polynomial functions have the same x-intercepts, they would belong to the same family. It's kind of like parents, you know? All right, so this just says you can represent it in the form, in factored form, and with a generic k in front, that would be the general equation of all members of a particular family. So if you had zeros 1, 2, 3, up to 10, you would just write them out here and then put a k, and that represents all of the different members of the family of polynomial functions with those particular zeros. But if you wanted a specific equation, then of course you know that you need to identify one point on your graph and you can get the equation. It'll give you the specific k value. All right, here we go. The zeros of a family of quadratic functions are -1 and 2. Determine an equation for this family. So a generic equation would be something like g of x equals k times x plus 1 times x minus 2. That's the generic equation. That represents all of the possible equations when you have zeros of -1 and +2, because k is an element of R. If we go back to up here, k is an element of R, k cannot equal 0. Okay, so there's the equation, general equation. If it wants two specific equations, then you would just put in any two values. Let's put in -1. So we've got this parabola opening down, and we can also say g of x is equal to, I don't know, 2. There we go. Okay, could have been anything. Any k value. All right. Now it says determine an equation for the member of the family whose graph has passes through the point -4, 1. So we're going to start with our generic. And we're just going to sub in -4, 1 and solve for k. There is nothing new here. Okay, so this is k times -3 times -6, and k is equal to 1/18. Therefore, the equation of the function with zeros -1 and 2 passing through, oops, there's a G on that, passing, oh dear, oh dear me, what's going on? I'm not sure what has happened. I'll just pause the video for a second. Okay, I'm back, and sorry about that. There's the solution. So the equation would be, the k value is 1/18 with your two factors. Okay, super easy, right guys? And it's the same process here. Now we have a cubic, and we're going to, oh goodness, we're going to do the same thing. So if you want a generic equation, you're just going to write, we could call it f of x this time. We're going to use k times x plus 3 times x minus 1 times x plus, minus 4. Okay, so opposite sign there of everything. That's the generic equation. So now we're going to write two equations for that particular family of equations, and there are a number of them. So think of the equation with the k in it as your last name, and we're just going to come up with a couple of the kids' names in the family. So let's say f of x equals x plus 3 times x minus 1 times x minus 4. There is one equation. The leading coefficient is 1. How about this one? F of x equals negative x plus 3, x minus 1, x minus 4. All right, so now we're going to come up with the name of the family member who has a very specific characteristic, and that is that they have a y-intercept of negative 18. So again, we're going to go back to our generic family name, which is k times x plus 3, x minus 1, x minus 4, and then we're going to sub in our ordered pair. Our ordered pair here, if the y-intercept is negative 18, is 0 and negative 18, because x is 0 when the y-intercept is negative 18. So we're going to have negative 18. We're going to put in 0, plus 3, 0 minus 1, 0 minus 4. Now when we do the math, that's going to be 3 times negative 1 times negative 4. So we get positive 12 here. So 12k is equal to negative 18, and k is equal to negative 18 over 12, which reduces down, let's see what goes into that. 6 goes into that, so that's going to be minus 3 over 2 is equal to k. What's the equation though? We're going to say the equation is f of x equals minus 3 halves times x plus 3, x minus 1, x minus 4, is the equation of the member with y-intercept negative 18. Okay? All right, and now it says sketch the graph. So you can see that we've got 3 zeros here. We want to graph these two kids and this one here. Okay, so we've got, if we look at this particular one up here, we're going to figure out the y-intercept. We just multiply these 3 numbers together. If there were a leading coefficient, we would multiply that as well. We can only do that when the coefficients here are 1, but they are. So minus 3, that's 12. So we've got a y-intercept of 0, 12. We've got a y-intercept here. This is negative, positive, negative, and again, this is going to be negative 12. This is a leading coefficient that's negative. The first one is positive. So if I go to graph this, I'm going to put all my zeros in here. So negative 3, 1, 4. Let's graph the first one, which had a y-intercept that was 12 and a leading coefficient that was positive. So I know I'm going to come from here, end here, because I have a cubic with a leading coefficient that's positive. So let me just think about how I'm going to do that. I'm going to, with my blue pen, then come from here. It's very difficult, guys, with this stylus that I've got. I'm going to come down here, through here, turn. I'm trying to maintain some symmetry here. There's the first one, okay? The second one is just a reflection of the first one, and our y-intercept was negative 12, so if I plot that, there's negative 12. Same zeros, And my leading coefficient was negative, so I'm going to start in quadrant 2 and end in quadrant 4. So for this one, I'm going to be coming from here. Sorry, that looks a little bit like an order 3-0, but that was just my hand. It's not an easy process here, using this keypad thing that I have. Okay, ish, like this, and so this one is f of x equals negative x plus 3 times x minus 1 times x minus 4. This one here is f of x equals x plus 3, x minus 1, x minus 4. And the next one is I'll do it in green, has a, let's just see, what's the y-intercept? We already were told the y-intercept was negative 18, right? So if I plot that, negative 6, 12, 14, 16, negative 18 here. Same zeros, but we are going to be starting again in quadrant 2 and going to quadrant 4 because this is a negative leading coefficient. So I'm going to have something like this going through again, maybe coming down a little lower. Goodness gracious, that's supposed to be smooth. And then again, it may or may not look exactly the same. There we go. This one was f of x equals negative 3 halves x plus 3, x minus 1, x minus 4. And we've got negative 3, 0, one of our zeros. We've got 1, 0, second 0, and we've got 4, 0. Okay? Label your y-intercepts. 0, negative 12, 0, negative 18, and 0, 12. Okay. So this incorporates a lot of what you've learned from the first chapter as well. Okay, on to the next example. Example 3 says, determine a simplified equation for the family of quartic equations with zeros at negative 1, 3, and this funky one at 3 plus or minus the square root of 5. Well, 3 plus or minus the square root of 5 is a real number, and it's just not a whole number or an integer like we're used to. So, but it's a legit 0, right? Like if you calculate this is 3 plus or minus 2 point something, which is 3 plus 2 point something and 3 minus 2 point something. It's legitimate. Okay, so we have to get used to using this radical notation. All right, so this is a process. You're going to have to memorize it. So just pay close attention, and if you don't get it the first time, you might have to just pause the video and go back over it a couple of times. All right, so we start with f of x equal to k times x plus 1. So we're just taking our zeros, changing the sign. And this is where this one, if we were to take this and put it in as a 0, it's going to be x, this is positive here, right? So it's going to be x minus, and we put this in bracket, 3 plus the square root of 5, close bracket, times x minus bracket 3 minus the square root of 5. Are you with me? So because this was positive here, we took the opposite sign here and here. We had two of them, right? We had positive 3 plus the square root of 5 and positive 3 minus the square root of 5. So I've just put them in just like I put in my integers here. Okay, that's the first step. Second step, we're just going to leave. We're going to work with these radicals a little bit. We're going to massage this. So then the first thing we're going to do is we're going to get rid of the brackets that we put in. So this is going to be x minus 3 minus the square root of 5, right? When I distribute that minus through here. And then similarly, this is going to be x minus 3 plus the square root of 5. Okay, now rewrite the first part. You always keep it all, right? Even if you're not doing anything with it. And now this is where it gets a little bit tricky. So if you stare long enough at this, you can see that there are two parts to these brackets. I'm just going to use a different color here. Right. And then in between, there's a minus and a plus. This is kind of like the result of factoring a difference of squares. So if we've got if we consider this like an A and this a B, and this here, this x minus 3 an A, and this is a B, we've got really A plus B and A minus B here. And if we have A minus B times A plus B, what did we originally have before we factored it? We had A squared minus B squared, right? Okay, so using that logic then, we could rewrite this. A minus B times A plus B is the same as A squared minus B squared. So what is A squared? Well, that's x minus 3 squared. And I'm going to put this in a square bracket. Minus B squared. Well, what's the square root of 5 squared? It's just 5. Okay? Interesting. All right. So now, f of x equals k times x plus 1 times x minus 3. And we can expand this out. This is x squared minus 6x plus 9. Go ahead and FOIL it if you want, minus 5. But this, you know, you can just square the first. You can square the back. And the middle term comes from x times minus 3 times 2. Okay, that's the shortcut for FOILing a perfect square. All right, we're getting there. F of x is equal to k times x plus 1. Again, we haven't done anything yet. And then this one is x squared minus 6x plus 4. All right. We're not going to expand this out. We're going to leave it in this form. Let me just think. Simplified equation. No, we are going to have to expand this out, unfortunately. Sorry, because it says simplified. So we're going to say this is k equals x squared minus 3x plus x minus 3 times x squared minus 6x plus 4. And I'll simplify this one more time. And then I'm going to have to FOIL this. This is x squared here. Okay, so f of x. I do not distribute that k through, and I'm never going to distribute the k through. I'm just going to leave the k out there. But this is going to be x to the 4th. This one times this one is minus 6x cubed. This one times this one is plus 4x squared. Minus 2x times x squared is minus 2x cubed plus 12x squared minus 8x, and then we've got minus 3x squared. Where am I? Plus 18x minus 12. So a trinomial times a trinomial should give us 3 times 3, 9 terms. 1, 2, 3, 4, 5, 6, 7, 8, 9. One way of checking. And then you're just going to simplify that. Gather any like terms. So you have only 1x to the fourth term. That's good. Minus 6x cubed minus 2x cubed. So that's going to be minus 8x cubed. 4x squared plus 12x squared is 16x squared. Minus 3 is 13x squared. So plus 13x squared. Oh, minus 8x plus 18x is plus 10x minus 12. Okay, you don't have to distribute the k through, and that is a simplified equation for the family of quartic equations with zeros at negative 1, 3, and 3 plus or minus the square root of 5. So notice here, we didn't FOIL any of this. We did not want to work with our square root of 5, so we just rewrote it in this form using the principles of the difference of squares, and then we expanded it out, simplified it, and then we actually had to do a lot of FOILing in order to get our final equation. Okay, so now that we have this, we can substitute in for f of x, 108, to get the actual k value. We don't know k, we know x is 2, so this would be 2 to the fourth minus 8 times 2 cubed plus 13 times 2 squared plus 10 times 2 minus 12. Bracket. All right, 108 equals k times, am I missing? No. 2 to the fourth is 16. This is 8 minus 64 plus 4 times, that's 52, plus 20 minus 12. All right. I'm hoping that I don't need a calculator for this. All right. 72, 60 minus 4. And then 16 minus 4 is 12. So k is 108 over 12. That simplifies down to, I don't know, 54 over 6 or 27 over 3. Oh, that's 9. All right, that's nice. Okay. So k equals 9. So f of x is equal to 9 times x to the fourth minus 8x cubed plus 13x squared plus 10x minus 12. And you can keep it in that form. Simplified really is just standard form, but your textbook actually leaves it in this form, I believe, so I'm going to let that go. Okay, example 4 says determine an equation for the quartic function represented by this graph. Well, we know that there are 4 zeros. So I am going to write f of x equals k times x plus 2 times x plus 1. You know, opposite signs of the zeros here. X minus a half and x minus 3. That's our family of functions, but we need to get the specific equation. So we're going to sub in the 0.1, negative 6. So, negative 6 equals k times 1 plus 2 times 1 plus 1 times 1 minus a half times 1 minus 3. Negative 6 equals k times 3 times 2 times a half and then times negative 2. And when I do my multiplication here, I get 6, 3, negative 6k is equal to negative 6. So our k is equal to 1. So our equation of that graph is, I'll just go down here, f of x equals x plus 2 times x plus 1 times x minus a half and times x minus 3. Okay, so let me just caution you about what the textbook sometimes does. And that is, it might not write x minus a half. It might write 2x minus 1. But if you want, you cannot change it down here. You can't change this to 2x minus 1, because all of a sudden now, if you had a 2x minus 1 here, you've got a leading coefficient of 2. That's not the same as this equation that only has a leading coefficient of 1. If you wanted to, though, you could write the fraction 0 as 2x minus 1 up here. And when you calculate then your k value, you're going to sub in, this is going to be 2x minus 1, so it's going to be 2 times 1, which is 2, minus 1, which is not a half, but 1. And when we calculate our k value, then we get 6 times 1 times negative 2, which is negative 12. And our k would be a half. And that would be okay then, because I would have 1/2 here, I would have my 2 here, and my true leading coefficient, if I chose to factor out the 2, is that 1. Okay? So this equation here, with the red included, is the same as the equation of the blue. But you can't have part of it. You can't just write, you can't right here change it to 2x minus 1 without adjusting your leading coefficient. Okay, so there may be some confusion. You might get a different answer than the book because you may leave it in fraction form, which means that your k value would be different. But in fact, it's probably correct. It's just that you've done it in a different form. Okay, all right. Thanks for listening.